So, in the name of God, the compassionate, the merciful, this is the first kind of practice session of our C++ TMP, template metaprogramming. And at the very beginning, we are going to have a question about Idris that hopefully will relate to C++ TMP. James, please.
Luckily, it's actually a question about C++. So here we
good.
have the vehicle in the Idris.
Yes, okay.
We have that power source type.
Yes.
And we're using the generalized algebraic data type to sort of fix it in. I was right. I've been set the task at work to port some Haskell code to C++, which does. It has a lot of data structures exactly like this, where they describe an abstract syntax tree.
Yep.
And an expression is when it is constructed, because the expression is split across lots of different types. It sets something like the power source here, sort of a ghost type.
Is it a phantom type or is it
phantom type? Yes.
Okay.
To true or false, depending on something to do with the syntax tree, something to do with the language, whether some extensions are used or not. And I had no idea how to express that in C++, because I was using variants from the standard library, and because I like to use the visitor pattern to sort of exhaust pattern match it. But I had no idea how to make a variant where some of the elements had a different template parameter.
Well, you can do that by compile time programming rather than runtime programming.
It's compile time in Haskell as well.
Right. And that is under the assumption that you when you said that you want them to have different template parameters or different, I think you mean template arguments. So that is suggesting that you have the values ready at compile time.
Yeah, so it's for type checking reasons. So like essentially it's either a true or false, this on the type level. And if it's true, then it contains no extensions to the language.
Right.
And so if it's set to false, then the variants are bigger. And if it's set to true, then they're smaller. And the idea is that this is to guarantee that none of the extensions are left over after the evaluation and validation. Right. So I need to guarantee that none of those parts of the variant are used if the template parameter is true.
Okay. So what you want is a non-type template parameter of type bool.
Yeah.
Which then, so you have a struct that takes a non-type template parameter, and then you specialize that struct based on true and false, and each of those have a nested type alias inside them, which describes which describes the different. I mean, this is the quickest, but you can elaborate on that, and you get, depending on the details of your problem at hand, you can get quite prettier designs. But this is this does the trick.
It does the trick. I mean, I guess I thought of that. The reason I didn't go for it was because it would involve writing most of the variant twice, which just felt wrong.
No, you can. Are you familiar with the expression problem?
No, maybe not by the name expression problem, at least.
Okay. it's a very famous problem in the world of programming languages. The origin of this name, I think, if well, as far as I can remember, is Philip Wadler. And the idea is that you want to be able to add both type constructors to a type and functions to a type without, well, functions that act that are applicable to a type without having to recompile or re-implement what you have already compiled or implemented.
Yeah.
Right. What you're telling me is that you don't want the repetition of the implementation, and the expression problem has so many different solutions, each of which helping with one or multiple of the various aspects to the problem. I have papers on that, so if you're interested, I can
Yeah, I'm definitely
point
interested.
you to them, especially because my solutions are in C++. So
helpful.
yes. Okay. Now, thank you very much for the question. Hopefully the question and the answer made sense to the other people on the call. Now I'm going to give myself some light. It's quite dim in here. Yeah. Oh, that takes more time. Just a moment. I'm still hearing you if you want to talk.
No.
Yeah.
Okay. Hopefully that's more light. This is meant to be, this is supposed to be daylight. So, all right. Now we can get away from this to C++. Please fire up your C++ environment. So I would like to, in the meantime, refresh you guys with so I take it that no one has watched the previous session's recording. I think the count was 0 last time I checked it. So
No, I watched it.
which
We'll
makes
give it a
sense
watch.
because you had very little time. All right. Now, once you're ready with your editors and your compilers and all that, I think the previous time we went through this one. I'm now going to review over this again because none of you have really watched it. So just let me know when you're done with your loading of environments.
It's good.
Good. I was watching my recording just was it last night? Yeah, last night. And I realized I didn't ask anyone for a joke in an hour and a half. I was thinking to myself, what did I do? An hour and a half without a joke? Oh, who wants to watch that?
Too interested, too engaged.
Well, I hope that I was true, but it's anyway. It will become a lot to take in without a refreshment. So yeah. Okay. So Jan is up and ready. Who else is? People are getting that.
I'm just
Okay.
updating my build tool.
Okay. Should I, in the meantime, maybe show you some code? If you can concentrate on what I can. Yeah, Mikhail, would you be able to? Or are you engaged? I'm battling my compiler currently.
Okay.
Well, you know what? Because you are the only one who was here the previous session. I'm just going to brief the others over the material. So and you have already seen it, so you won't be missing. Now, so I told the other guys, Mikhail and Daniel, who were here and on the previous call, that there are these things that colloquially in C++ are referred to as meta functions. They are relatively outdated these days, but because you need to see them, because you will need to navigate through C++ TMP, I would want you to see them. So meta functions are these structs that are templatized, and they so-called return. And when I say return, I'm putting it in double quote because they don't really return anything. They actually type reduce to either a value or a type. And so they do that by following a human-to-human convention in the C++ community. If a templatized struct or class has a static const expert data member called value, then it's considered a meta function that returns a value, and this name is not checked by the compiler. This is colloquial convention, human to human in C++ community. If it has a type alias called type, TYPE, and that's just a name, then the C++ people, when they see it, they realize that this is meant to be a meta function that returns a type. Now, here is your first example. Suppose that you wanted to write a compile time factorial thing. Right now, you would get a struct, which is type parameterized by the compile time variable, let's say called n, right? The real type of which is not really of interest here, and all it does is that it's it says it's two specializations. Sorry, it's one general, it's one primary template with one specialization. Right now, the general the primary template says that given an n, what I will do is that I will produce this product of n and the factorial of n minus 1, and as you can see, there is extra syntactic machinery here for acquiring factorial of n minus 1. You have to state the n minus 1 within the angle brackets, because that's a parameter to the that's an argument that you sent at the compile time level as a non-type template parameter to fact, and then you acquire its value static data member. Right now, James, in the recording of the previous session, there are two places where I answer two of your previous questions. I would be delighted if you take a look. Now, the other thing is that, okay, then you specialize this template fact for the value 0, and you say that, okay, the value that we're after is 1 for that very specific case. Now, I showed this to the chaps in Compiler Explorer. So I can just go to Compiler Explorer. Oh, it's still here. Right. And I said that, okay, if you want factor 10, and you see that you know in the equivalent assembly, this is hard coded because the computation takes place at compile time, which means that you will not have, well, which means that you will have 0 time at runtime spent on the calculation of this number. Right? I can change that to, let's say, 50, and if it can perform 50 calls, right, it will give me some number. Okay, it's just too high, so it has overflown and it's 0. Right? Now, anyway, the thing is that this is already computed for us at compile time. Now, like I said, you know, oh, by the way, this is, I take it that this is too small, right? Maybe, I think this much should be good, even for a mobile phone. Right. Now, so, like I said, this is relatively old-fashioned, and the idea is that I will now teach you the C++ 23 version of you know, metaprogramming, compile time metaprogramming, which, by the way, is not in the book, because the book was published in 2017, and the standard that it made it to was C++ 17. Now, one more example, and then you will start coding. Suppose that we wanted to have a function that would tell us whether or not a meta function that would tell us whether or not the argument that it is passed to as a non-type template parameter is 0. We would have a primary template for every n that would set a static const expr data member of type bool called value for the is0 of n to false, and it would have only said that that's true. Oops. When the argument passed is 0, is actually 0. All right. Now, James, going back to your question at the very beginning, this is how you would do what I said. Now, like I said, I imagine that there can be more interesting, you know, solutions. This is just the crude that comes to mind immediately. Now, so enough of the meta functions. You know, usually when I teach these things, the meta functions are kind of the rest of what my students are going to experience. But because you live in a post C++ 23 era, I can now see, you know, give you less torture and the same amount of pleasure, I hope. So without any further ado, we are now going to go through this thing. Right. Now, so this is the gist of a project that you would also kind of contribute to in your coursework. The idea is this: we would like to have a compile time metaprogramming library for dealing with lists of variadic values. So we would like to be able to, let's say that we are simulating the list library of Idris in C++ at the template metaprogramming level. Now, so a list has a a famous API. So let me try to maybe find that.
You seem to have lengths parameterized in your types for the list in template programming. You have ends there, don't you?
I'll get there. Please
Okay,
keep your question.
Sorry.
I'm at the moment struggling with my.
There should be a vect sort.
Right. Okay. Let me see. Okay. Let me get to the very bottom, please. Where is it's not this one. Oh, come on. Ah, okay. Okay. Looks like we're getting there. Right. So here is the vector,
Standard
data structure or well, ADT of Idris, and as you can see, it has a good number of functions defined on that ADT. Now we would like to have the equivalence for the C++ template metaprogramming. So for example, there is this length thing, there is the famous ones. What are those? There is cons and snoc, and there is filter, there is tail, there is head, there is last, there is init, take, and all that. We want to have each of these functions for our C++ template metaprogramming list library, right? Now, and this is the point where you come to see that I chose Idris specifically because of its similes to what we're going to experience. Now, so to that end, the first thing that we would want to have, and imagine that this bit of it was not here for the moment, right? The first thing that we would want to have is this. So we would want to have a struct that is called list, right? That takes a variadic number of non-type template parameters called x's, and all of our lives in these sessions will be dealing with that. Now, I'm going to uncomment this bit, but not explain it at the moment. There will be a time when we get them. Now, these comments that I have left higher up, they are important because they are trying to teach you what the meaning downstairs is based on the what is it? Based on the equivalent Idris. Now, for a moment, you can imagine then that this list thing is actually something that for a numeric type tie and an implicit parameter n gives you at the meta level, and this is my syntax. I should remind you that this is not the Idris itself. There is no such thing in Idris as meta, right? This is me putting the meta here, right? Now it gives you a list of n tie values. Now you see that in Idris, list doesn't take a length. Vect does, right? Now I am intentionally not putting vect here because there are genuine differences, even though this is a dependently typed data structure. There are genuine differences between vect of Idris and the list that we have here, and there are also differences with list. Right, so it's something between list of Haskell, mostly list of Idris, and vector of Idris. It's not quite vector of Idris either. No, we're going to see how. Now, the first thing that I would like to do is cons. Right now. So I am going to now ask Niels to tell me what cons does.
What const does?
Yes.
Just const or const expert?
No, cons, C-O-N-S in Haskell or
Cons.
in yes, or in Idris. So in Idris that's like the colon.
Yeah. It's like the append function.
More like the prepend.
Yeah, prepend.
Yes.
Sorry.
Yes, correct. It's indeed so. It's a prepend, right? In that it takes a new element and the list, and it prepends that element to the list, giving you a new list, right? Now, so now in the old days when I was not aware of snoc, right? I was aware of cons, but I was not aware of snoc. I wanted to have something which is a naming which is bidirectional. So I thought about prepend and postpend. Right. So that therefore, I didn't name this prepend thing as cons and then this one postpend as snoc. But you get what that is, right? You are all familiar with snoc, SNOC, right? So what snoc does, now Mikhail seems a bit lost. So
yeah.
what snoc does is that it puts the element to the end of the list, and as you know, list in most functional languages are engineered in a way that adding something to the front of them is O of 1, but if you want to add something to the end of them, it's O of n. So there is this difference. Now, I would like to walk you through the prepend, but by first asking you to look into the cons of, let me try to find it, if I may. Right. So this is cons as one of the data structures. Sorry, one of the type constructors of vect of Idris. And by the way, is this readable? Why does this? Okay. So what it does is it takes annex, and then a vector of length n of that same type, and it returns a vector of the length n plus 1 of that same type, right? So let's see. So this is the type signature in Idris. And now let's see how you do that in C++ TMP with this particular list struct that we have. So we would like to have a prepend function, let's say, that takes a list of x's parameters, and these are, remember, these are arguments, and these are non-type template parameters. They are compile time, right? And what it wants to produce wants to have this other non-type template parameter added to it, right? Now that is easy because, like I said, the pack that you receive and you work with is a more flexible thing than the vector that you get in Idris. You can simply put X in front of that same pack and then instantiate this type, right? And then return that instantiated value, by doing which you have a new list at compile time. Now this is compile time because there is a const expr as the return type, and there's auto, which means that you don't really care about what the type is. It's on the compiler to figure out the type for you, right? Now, I will give you 30 seconds to come to peace with yourselves regarding these 3 lines, especially with being able to relate to the kind of meta Idris comments that I have put at the first 2 lines, and relate that to the C++ code downstairs. Your 30 seconds starts now. Okay, who's not at peace with this? Okay, this is a very peaceful community. Good. Good. Now, so I would like you guys to put these lines in your editors for me, except for the requires here. So don't put the requires. Put lines 19 and 20 and the open and close curly braces with the trailing semicolon, and then this single line 36 in your editors. And once you have done that, please compile that for me. Let's see whether I can give myself some tea pleasure.
How far were we supposed to go?
Well, you are only supposed to put actually 5 lines: 19, 20, 21, 20, sorry, 30, and then 36. So
Not the methods.
no, none of the and by the way, we in C++ we don't say methods. Methods
Okay.
is Java. We say member functions.
Member functions. I'm so sorry.
Apology accepted. Okay, so empty struct list, and that without the requires clause here, right? You just put the why don't I just do it for you? I should apologize. Let's see. Here we go. Lines 20, 21, 22, 31, and then 37.
37.
Yes, 37. The prepend. The empty struct, template parameterized struct with prepend. Is there any of you who is done?
Maybe.
Okay, well,
See what GCC says. Let's have a look. That's fine. One warning, unused parameter. That's fine.
We include the size since we're not using it here. Line 28.
Sorry, what was Jan? What was the answer?
Oh.
So, what was the question? Jan?
Oh, using it in this example.
The
28 to 30.
Right. Sorry, you cut out.
Line 28 to 30. Should we include that?
28.
28
30.
to 8.
No. You
Yeah,
don't
okay.
need to at this point. Not at this point. No.
Then
It compiles.
Very good. Okay. Now, once we have everyone having that compiled, we should test it. And I will tell you how to test it. Has anyone not been able to compile that, or are you still on your way?
I'm done.
Okay, very good. Okay. James, are you also?
Yeah.
Compilation. Okay, very good. Now let's use that. You should be able to do this. You should be able to put this line 56 in. And in case you needed this explanation, those previous things need to come outside not every. They need to come outside the function main that we are now using, right? In case you didn't notice that. You can't put those inside the function main. Now, what this line is trying to do is instantiating the struct list with the non-type template parameters 1, 2, 3, 4, and then prepend 0 to that, which will give us the list 0, 1, 2, 3, 4.
Or that my IDE like tells me the type of L1 with 0 in the front. That's cool.
I didn't get the question.
No, I was it wasn't a question. I just said my IDE tells me, since there's a const expert, what what L1 is.
Okay, have you put auto here?
Yeah.
Okay. Can I see your would you mind sharing?
Yeah, sure.
And let me see whether I can set the sharing so that multiple participants can share. Okay.
Let's see. Here we go.
Okay.
See.
Are you sharing now?
Yeah.
Okay. Now let me see whether I can switch to your. I don't see your screen now. I'm not sure. I'm not sure how to switch between the screens. Well, I'll stop my share. Okay. Okay. Now I can see your screen.
Yeah.
Okay. Now, so you're oh, you have put a lot. Okay.
Yeah, I commented it out.
Right. That well, on line 15, there is something which is wrong. So you have an arrow to the right. Yes, that
This
piece.
is my IDE.
Oh, I see.
Gives him
It
cool.
tells yeah. So you can also see here that it has
Right, I
given
see.
me yeah.
Uh-huh. Okay, cool. Ooh, that's very helpful.
Yeah.
Wow. Okay.
That's
Okay, well, you got the right answer.
yeah.
Yeah, you got the right answer. Okay, very good.
Got the
Very
right
good.
answer with the cheat sheet.
With a what cheat?
Sheet.
Ah, cheat sheet.
Yeah.
Cheat sheet.
Yeah.
Okay, yes.
Yeah.
Yes, true. It's and it's a very good one. Um, does everyone get that behavior?
Yep. Or
Yeah, very good. Very good. Now, your next task, and I was hoping that you would not copy everything from my screen, would be to write the post pend function. And if you're writing something, you will be required to defend your code. So the simple copy paste will not get you anywhere. Right? Yeah. You have enough time for me to go get my tea. That's yeah. Just a moment.
Hmm. Oh.
Wait, don't we have postpend?
No.
Go.
Woo.
So when I try to use or do it on L1, like pass that, or use the member function, it my IDE wouldn't tell me what the contents of the list are or where.
yeah. Well,
Yeah.
if you press the type thing, the ID thing,
Typing?
yeah, you got dot
Like-
dot dot in these ones. Just press it and you can see it.
Right.
See, I'll try.
That's called these things are called the angle brackets.
Yeah, but I forget
Uh,
what they're called.
That's fine. That's fine.
I
just
usually
wanted
call
to-
them crocodile
Yeah.
signs.
crocodile signs. Okay, there
Because in when we were learning like maths when I was 6 years old, the teacher was like, "This is a crocodile and it eats the bigger
right.
number."
Right. Okay.
I remember being taught that as well.
Yeah. There's also something slightly similar, which is called the chevrons. So you can, but they are. It's not exactly the same. The
Is it like
chevrons
the
are.
double quotes?
Yes, it's more fancy, you know. It's not just the greater sign and then the less than sign. It's chevrons. It's more fancy. But you know, some people call these chevrons. You know, I don't like to do that. And then and the C++ community, those are not, you know, referred to as the chevrons. So, yeah. Anyway, so who's done?
I'm done,
You're
I think.
Was it
Okay.
prepend or postpend?
Oh, I didn't try to
Postpend.
build it.
Postpend. Yeah, I should try.
Yes,
build it.
you should always, you know, I should refer to an instance with Jeremy Gibbons. So back in 2012, I was in this workshop called workshop on generic programming. One session of which was chaired by Jeremy Gibbons. So he was talking to the audience about something, and someone asked him about the runtime of his programs and of his particular program that we were talking about, and he said, I don't know, I mean, I never run my programs, so long as they compile, they're good. So you know,
Right. Yes.
but you should compile them at least. That's I mean, you're fine not to run them, but you should at least compile them.
Yes.
Has anyone failed to compile?
I haven't failed to compile, but I'm getting like a warning from my editor that postpend should be marked no discard.
Can I see that?
Yeah, sure. Oh, let's make it bigger. Here.
Oh, really? Okay, that's interesting. So, well,
what does it mean?
Well, these are quite new things. They are compiler directives. I don't know how to quickly explain that to you because it takes, you know, are you familiar with the what was it, sorry?
They make the compiler do something.
They do, but they don't have you know, are you familiar with the programming language IFL?
No.
Magna has mentioned it a couple times, I think.
Okay, well, so there are in that language there are that's the model language for doing like preconditions and post conditions and invariants and all that. You know, C++ has adopted a model for doing those, and it's if you provide some of these directives, then the compiler can perform better jobs on your code, right? But these are this is just optional at this point, and I don't think that they will ever make them compulsory, right? But because they're off topic in this module, I prefer not to delve into them. Right.
Yeah.
Now, has everyone compiled their managed to compile their code? Now, unfortunately, I showed you the solution before, asking the question, which means that I guess that all of you have put it as a member function. Postpend is a member function for all of you. Is that right?
I have two functions, one which is outside and one that's inside the struct. So yeah.
Right. And your code compiles.
I've not tested that yet. So
okay. Well, here's your test bed.
Is there a difference between having a member function inside the struct and outside? I mean, I guess because of the way you phrased your question.
Well, your question is something, and I'm guessing you mean something else. So you ask whether there is a difference between putting the member function inside or outside, right?
Yeah.
You can put the member function inside both the declaration and the definition.
Yeah,
or
I
you
can
can
see.
or you can put the declaration of the member function inside the body of the class and the definition of it outside.
Yeah.
And the difference is that you can then, if you do the second one, you can take the implementation to another compilation unit and get separate compilation. Unfortunately, that is not available in C for templates, as I explained, right?
Yeah.
Now, I don't think that you meant to ask that question. I think you meant whether there is any difference between making postpend a member function or like prepend what is called a free function.
Yeah.
I think that's what you meant to ask. And that was that was what I was hoping that that you guys would get to by kind of experiencing with the postpend being a free function and then realizing this is not really possible. Now, has anyone tried to put it outside as a free function, not as a member function that is just okay? Now, very good. Now give it the following tests. Let me see. Where is the shared bottom? Come on, where is it? Why can't I find it? Oh, here it is. One, two. Okay. Try postpending 5 to your L1 and producing L2. Now, this is the syntax for when it's a member function, right? Now, you should try this, and if you have it outside, you should that would be the call would be something like this, the prepend. So you would say postpend within the angle brackets 5 within the round parentheses L1. That would be if you have it as a free function. Now, who wants to get me to see the result of this being compiled? I'm more than willing to stop sharing and give you the share. I am going to ask Jan to do that.
Sure. How do I output this? Let's see.
Okay, I'm stopping my share now.
Yeah. Do I just compile? I mean,
no, just show us your editor.
Sure. Which school is that? There we go. Is it showing my editor?
It is showing, and
Is it
It's
okay now?
relatively small. I
All
would
right, let's make
I
it
would
bigger.
appreciate if you can. Yeah, yeah. That's good. That's excellent.
Hmm.
Okay.
So, do we run it?
Did you compile it?
Let's see if it compiles. Variable L2 set, but not used.
That's fine. That's a warning.
Yeah,
That's just a warning.
it's
right?
for the test.
Right, that's true. So let me just put this here. Right. Okay. Okay.
Yeah, put that
Now,
in.
good. So we know that this one. Right. Now this is the what was it? This is the member function that you are using. Now, would you mind compiling your you testing your free function for it?
I feel sure, and that was putting it like this here.
Mm-hmm. Very
Yeah.
good. Now you probably want to give it a different
A
name.
different name. I saw that. Yeah.
Yeah. And would you mind compiling it now, please?
Error conflicting declaration. Oh, did
Can I see your
Oh no,
Can I see your error message?
isn't that showing?
No.
Oh, perfect. How do I? Give me a second. There we go.
I still can't see it.
No.
It should be split. Oh no, it shows just the. Oh jeez. Please.
Right, you can share multiple.
Wait. Actually, I can do this. Wait. I was thinking, I can literally just yank it from here and put it in a comment here.
No,
well,
we can't see the side of it.
Oh
Yeah.
no, okay.
Yeah, you know what?
This is terrible. I am very sorry. There.
This is the warning.
No, it's an error.
No, this is the error. Variable L2 set but not used. No, this is not an error.
Well, it is an error, but that's because you have where turned on.
Right. Yes.
I shouldn't have
yes,
where
that's
turned
right.
on.
Yes.
Okay.
No.
Yes. Yeah.
All right, turn that off then. Give me a second.
Yes.
Yeah, get rid of.
As well.
That's fine.
Right.
Well, but
It'll
change
give you lots
change
of
the.
warnings.
Yeah. Let's see. It's a better idea. No. Wait. Go back to your settings and set your STD to C++23, please.
Sure.
Yes. Okay, now recompile, please.
Yes. Give me a second. I'm doing this in a couple of warnings, but it compiles.
Yeah, mine compiles as well.
Okay, well, I'm
Yeah.
totally surprised. What does it?
I guess it considers one separately from the other, even though they have the same name.
Right. Okay. Here is what I was trying to do. So what I wanted to do, you see, this should compile. That's true. What I was hoping for was that we can, when we're doing postponing, the 0 comes after the 1, 2, 3, 4 in the call on line 40.
Yep.
Right. So on line 39 at the moment, you see it's L1, then the 5 that we want to,
0 should be at the end here. So
right.
It's like
so no, that's not the point.
Oh, I get an error now.
Okay.
If I had the member the mer function first, and then the free function, and then when I try to
Do it the other way.
no, try to arguments were provided. But no, never mind. It's just because I did wrong.
Okay.
Everything works.
Let me try to explain the concern here. You see, when we want to prepend something to a list, we want that thing to be first and then the list. Whereas when we want to postpend, this is my concern. I wanted to design it this way. We want to switch the positioning of the two, because that thing should come at the end of the list, right? Now, with the free function syntax that you have at the moment, the thing that you're postpending, right? Now, if you go to the let me, maybe I should share it, and then
No, it's
will be
okay.
easy.
Just this works.
Postpend. No.
It's
on line
excess and then the very attic.
35, yeah, on line 35, at the very beginning of the line, you say template, and then oops,
Click some buttons. Yep. Template, and then auto X, and then auto.
and then auto X, and then auto ... X's. Whereas I would have wanted that to be flipped, so that it would have been right.
Yep. Let me just do that for you.
Because then the order is right. So you want the X to come after the X's, right? And therefore you would want to. Now this one would not compile.
No.
Yes.
Oh,
Right. Now tell me why, please.
Because we're giving it 5 as an argument instead of the list.
No.
No matching call for can a template ignore? Could not match 5 against 0.
Because I can explain it.
Sure.
Please.
Because it's matching templates, and so the auto X's is going to be, that is the template parameter for the current list. And so it's 0, 1, 2, 3, 4. And then when you call it with a 5, you can't unify that, because you need it's the first template parameter that you're providing. So that should be the auto ... X's, which you've then said is the same as the list, which is X's ... And so 5 does not.
Right. Why can the compiler not figure out X's ... from the parameter L on line 35?
Well, it can. I guess
then why is it failing?
Because what it can't figure out, or because to me it seems like when you put the 5 in, that fills the first template parameter. So it can't unify it. So it's figuring out that it's 0, 1, 2, 3, 4, but it's also figuring out that that doesn't equal 5.
Yes, that's true. So it has conflicting information. That's the point. And the thing is that none of those pieces of information has priority over the other one, right? If we had a rule which said that, well, look, when you have something explicitly passed to you as the L, then you should fill that one first and then go with the rest of the choice of the template parameters, then it would have been fine to do it this way. But now it is not, and therefore it gets conflicting pieces of information of the same level of priorities, right? Now that's the reason why this design fails. And because I wanted to have the postpend to come to the right side, to the right hand side of the list that we are dealing with, right? Therefore, I had to put it. I mean, the only way that I could think of was to make this a member function, because then I can say the list, and then to the right of it, what I want to postpend to it. You know,
Should I
so
stop sharing, by the way, or
you can, yes, you may, yes. Now, I wanted you to see this and to experience it because I wanted you to see it for yourself, feel it for yourself, that in software engineering, there often is not that you don't have a solution for a particular problem. It's that you have multiple solutions, but your art is to choose the best option as a software engineer, right? You have a set of constraints that you have to juggle around with, and you know, try to see whether you can really get something which fits your needs. It's not that in the end you can't produce that number, you know, that list of 1, 2, 3, 4, 5. You can produce that, but it's a matter of how you produce it, with at what time, at what cost, with what syntax, and things of the like. You know, that's called design exploration, and now you're seeing it. Now, okay, let's go back to me sharing, and hopefully I will not again show you the solution before asking you the question. Right, so let me go to here. The next one is null. So we would like to write a null function that returns a Boolean given a list that tells us whether your list is null. And by the way, these things that you see at the moment, they belong to pre-C++ 23. So in the last years when I used to teach these things, I had all these you know, guidelines for my students. They are outdated now. You shouldn't try to follow them. You have much better tools now. So please, you have like let's say you have 3 minutes to implement the function null that figures out whether a list is null. Oh, by the way, and it's a good idea to look into the address for now. Here's the address for now. One minute past.
So is null a member function?
That's for you to decide.
Okay.
Yeah. 2 minutes passed. You're done. Good. And you've tested it? You've compiled it
Yes.
and you've tested it. Very
Yes.
good. Good boy. Yeah. Okay, time's up. James, show us your code.
I didn't get it.
You didn't?
No, I couldn't remember how to
Hmm.
match the empty
Okay. List.
parameter pack.
Okay. Let's see. So fine. Then we'll go to Mikal.
Yeah, same issue here.
Really?
Yeah.
Is it
Okay, well,
just-
Niels, you're next.
Yes.
I'm just gonna stop sharing. Okay.
okay, yeah. Mm.
Oh,
Okay.
yes, of
Yeah,
course.
that makes sense.
That's
That
so
makes sense.
annoying.
Mm.
Well done, Nils.
Thank you.
Yeah, very good. Very good. You see that the second overload is not a function template.
Yeah, that was my mistake.
Right. Now,
I figured I didn't need a type because there it's just empty.
yeah, that's true. Yeah. So now, Niels, just a quick catch on your coding style. This is nitpicking on you. On line 26, you write
Yes.
auto and then a space and then the ellipsis, and you attach that to x's.
Yeah, I did it the
So-
wrong way, and then it.
No,
complained.
it's not that. No, that's a compile error. That's a compile
Yeah.
error.
Yeah,
What
yeah.
time-
So
what
I
time- what
did
time-
this,
Uh-huh.
and then it auto to that. But I've
Okay.
done this to
Right, I see.
yeah.
Okay.
Yeah.
Okay, very good. Very good. So you know what I was talking about. For those of you
Yeah.
who probably didn't get it, so the ellipsis reads better to people like me who are very picky with the syntax. Reads better when you attach it to the thing to the left and you give it one space to the right. Yeah, very good. Have you tested it? So show us your right.
Yeah.
Okay. Okay.
So here, and then you can see I
Right,
printed here in
right.
the terminal.
Your output. Okay, very good. Very good. Well done indeed.
Thank you.
Okay, any questions? Is everyone good with this? Right. Now let's let me share back. Right. So let me show my solution, by which I would probably this is the no see. Where is oh, did I not implement it? Entirely possible. Oh, I didn't. Okay. My editor crashed. Why?
It dislikes you.
Okay. So here is my implementation, which you know is is not as functional programming as yours, Niels, but I am trying to give you a clue on something else. When you have a more powerful tool that makes the job easier for you, you should use it. Right? Now, I could have gone for the pattern matching. I could have gone for that, but I didn't, because this is one of the peculiarities of the these lists, these compile time lists that we are dealing with. They know their size, even though it's not a parameter that they pass around. Right? So you can simply call size of ... on them and get the size. And amongst the other things that you can do with it, you can test it for equality against 0. Right? Now, please.
Does anything with the variadic ... have a size of implemented just from the by default, I guess? Is it
Yes,
the right?
every parameter pack can be tested at compile time.
Oh yes,
for
no, we
its size.
did do this. Yes.
Yes.
Very cool now.
Yeah.
Yes,
At compile time with the size of ellipsis.
Size of ellipses. Right on.
Yeah. So that's the way that I do it. And you see here is one of the differences between Idris and these lists. So if this would have been a piece of Idris code, it's taking some sort of n as an implicit parameter, right? And then it's saying that, okay, I have a list of something. I don't really care about what that thing is. All I need to check is whether this n, which is the size of the list that is implicitly passed around, is 0. Right? Now this is not Idris, right? This is kind of my meta syntax for Idris. Right? Now, here is one thing more. Now, if you go to these, if you go to this one, you would see that the comment that I have here is that provided that the type tie is a num, then the rest of it, right? Now I've changed that here to literal type. The fact is that the types that are valid here in place of auto need not to, from C++ 23 onwards, to just be numeric. They can be any type that is literal. And that's quite complicated for you guys, I'm guessing. But in case you need to know about it, here it is on CPP reference. Now we'll see some of that when we get to the function map. But for the moment, just bear in mind that you can go with types like string, with types like I don't know, enums, with all sorts of user defined types, so long as certain relatively complicated set of rules are met. Right? Now we'll see one of that. Actually, it will be very interesting when you see it. You will come to appreciate the freedom that you are given in C++ 23. I hope. Now, what's next? So are we done with null? Any questions?
I can add a question about the literal type.
Tell me.
If I create a struct that only has one field, and that is also a literal type, does that make my struct a literal type?
Well, it has to be either default constructible, or and this is what you would have been seeing if you hadn't asked that question, or the constructor needs to be const expr.
Okay.
Right, now we'll see that one. If you can't grok it at the moment, don't worry, we'll see it. Right now, so let's see what's next. It's head, and so I would like you guys to implement for me a head function. Where's my Visual Studio Code? So let me get the header.
I have to get going because I have a class.
Oh, I see.
I can implement head. It's fine. Implement head.
I mean, just do what you should. Do what you should. And I'm going to say that you have 1 more minute. Okay, time's up. Who's done? Okay. Okay, you need more time? The rest of you, James is done, but
I don't like it though. I don't know if it'll be fine.
okay.
Wait, does it compile?
Ah, good. Now. Okay, Mikhail,
Okay,
go
sorry.
on. Show us your code, please.
Me?
Yes.
I wanted to see if it worked first. So, but yeah, sure.
Well, then do it in front of everyone.
Yes.
This thing.
Yeah, that's the thing. That's the thing I wrote.
Okay, that's quite good. Now, what did you not like about it?
Yeah, I like it, but I got an error at first because it was like this, and I was like,
Right. So you had forgotten the semicolon.
Yeah.
Okay. Very good.
Okay.
Very good. Excellent.
Is this the one that's good? Okay.
What was it? Sorry.
Is this the one that's good? You can spoil it. I need to run, please.
Yes.
Okay, that's
you can. You just go away. Go.
All right.
Just go. Yeah.
Perfect.
Okay.
Thank you so much for today. Bye.
Thank you very much for showing up. Yes. Right. Now, whilst he is doing live coding for us.
I guess.
Yeah, that's just a warning.
Yeah, I just wanted to see if it could give me the number like that.
Okay. Okay, excellent. Now, let's see. So is everyone happy with this implementation on line 39 of Mikal?
Yeah. I
Okay.
tried to do it in a member function, but I couldn't figure out how to unpack the periodic.
Show us your code, please. Mikal, yeah.
Let's see.
You know, the
Damn
entire point of having these practice sessions is that you get to discuss the different solutions and you get to build that analytic mindset for producing C++ TMP. So if you have something that produces challenge, just bring it up, please.
See. I tried to do something like I know this is not correct because this would be like me telling I'm giving the argument that will be passed anyway.
By
so
the way,
I
you have a
would
tick
like
on line 13. I think you have a tick after const at the very end. Is that so? Is that a tick? Yeah, between const and open curly brace. Do you have a tick? No, you don't. Something is showing up on your screen. Oh no, that was on my screen. Sorry. Right. Okay.
yeah,
So you see,
I know
you're now inside. You know, you're inside the struct.
Yeah.
And it doesn't
so
really matter.
I have
whether...
access to this, right? I could, but I need to unpack it somehow.
Well,
and
here's the quick answer. The unpacking of a pack, or the so-called pack expansion, has a set of rules regarding the places in which you can do that. And I did teach you those, I think either in the last session or in the one before. I think it was in the one before, right? Yeah. Now, so if you watch that, or if you read that chapter of the book, I think it's chapter 9, if I'm not mistaken, right? Is it, or is it 12? No, it's 12. So you get to see that there are specific places which you can only perform pack expansion, right? And that's not, this is not one of them. Now, what you can do is that you can specialize list the struct for auto x and then auto ellipsis x's, and then place a member function head in there.
Oh yeah, I just
But if you do that, so that would be you specializing this. You know, you have you need to have the primary template, and then you give it a specialization.
Yeah, okay.
But
if you
do that, remember, if you do that, because there is no code share between the primary and any of the specializations, that means that you have to duplicate all the member functions of the primary for the specialization.
Okay.
Now, I think that means that even though this is possible, it's not a good design.
Yeah, that's a no-go, duplicating code.
Right. Very good. Very good. Now, I'm sorry that I had to, you know, tell you all the answer myself. This is not my usual me, right? But we are short of time, so I thought that I should make it faster for you. Now, we haven't had any jokes, so I'm gonna ask you, the three of you, to each tell us one joke before we say goodbye.
Okay.
At the same time?
I don't think that will really be enjoyable. Okay. Right. I'm gonna start with Mikau.
I don't have a joke, but I can tell you a Norwegian expression.
Let's go over it.
Okay. Have you heard the expression that there are owls in the moss?
Owls in the moss. Or
Yeah, the moss.
moss. Okay. No, I haven't.
What do you think it means? Just based on the context.
I don't know. Maybe it means that they you can track them because the moss shows their footprints or anything.
Oh, well, if you were out hiking and you saw an owl in the moss, what would you think? That's kind of strange. It just means that something's not right or something strange.
Oh, I see. I see. Okay. Okay. Very good. Thank you. Thank you. That was nice. Uh-huh. Now, Niels, your turn.
I seem to only get sick in the weekdays. But it's because
So
I have a
unlucky.
weekend. It's because I have a weekend immune system.
Okay. Okay. Well, well, but you see, it's still very unlucky of the person.
Yeah.
Yeah. Okay. Because just because you don't have an antivirus during the weekdays, it doesn't mean that you should be getting a virus. You know, it's yeah. Yeah. Okay. James.
I don't know if I've told this one before, but I decided to sell my vacuum cleaner. It was just collecting dust.
Right. Okay. Yeah. Yeah. That was good.
It's a good one.
That was a good one. Yeah. Okay, guys. That was great job. I'm now going to stop the recording. Where's the recording?